Hi guys, I appreciate you for being here after a long day. Amazing that you have still the power to listen. Okay, we're gonna have a short discussion about all night and any weather vision system. I think we can all agree that we want our ADAS system and our AV system to be able to work 24/7 and see night as a broad daylight, and weather should not matter. If we really want to have a solution sometimes out there, we want our neural network or any other algorithm to be able to work with a good enough image feed. And we need to face the reality that 65% of the time is a challenge for the current sensor suite in the cars. So we in Brightway, in the past years, invested a lot to be the first night and all-weather camera system, powered by our own gated vision technology. And I invite all of you to come to our booth and to see some more videos and more information. We are in booth 231. And this camera system can address all the perception requirement for the automotive industry. We are ready to the market in terms of qualification, the economics, and POCs that are already available. So we talked about that 65% of the time is a challenge for the current sensor suite, but what are the challenges? So we will talk today about 5 types of challenges. There are more. There are even more challenges in daytime, but we will talk today about dark environment, uneven lighting that you will encounter driving in Tel Aviv, a lightning city, but still you have uneven lighting which affects the current sensor suite, heavy rain, snow, and fog. And we will show what our technology brings there. So we in Brightway, when we think about the future of AV sensor suite, we think about the fusion of bringing both the good in the two systems, bringing the visible light, which brings all the goodness that you know today, with the colors and the signs reading, but also fuse that with the gated imaging, which provides you the low visibility conditions, adverse weather, road surface segmentation, and full distance view. So here you can see some, it's not the best screen that you can see it, but you can see how a fusion would look like. You will get on the top right a visible camera feed, on the top left the gated imaging feed, and at the bottom you can see a fusion. This is an example of 70% gated, so you can see the image from the left, but also you can take the visible image from the right and fuse that together, creating a frame for your neural network, for your algorithm with much more information and easier to detect obstacles, road signs, etc. So back to the challenges, let's look about uneven lighting. This is a street in Sweden. It's a lighted street. There is nothing strange or unique in that street. You got lights every 20, 30 meters up in the road, but this causes an uneven lighting, which you have darkness across the road, and it's harder to detect pedestrians or obstacles, comparing to the Wisdom technology and the camera that we're using, which create a uniform lighting across the scene. You have the same amount of lighting in the near field and in the far view of the illumination, so this is why it's easy to detect obstacle, and you have more sharp and the contrast is higher in the image. And we will show some comparison in raining, comparing thermal camera, visible, and the gated imaging. Okay, so what's the issue with the visible HDR? You can see that if you're comparing the two images, you can see that we are unaffected from the rain droplets and the backscatter. Backscatter is the returning light coming from the obstacles in the air, coming from in this case, from the droplets. So this is why you still get a very good contrast in your image. Oh, sorry. Okay. And now we can compare that to the thermal imager. I don't think I need to elaborate a lot more than that, but you can see how rain affects the thermal imager, and you still get the same image with the gated vision. Let's talk about snow. In Brightway, it's pretty fun to walk. We are chasing adverse weather. We are chasing darkness. So last winter, we sent a team to Lapland to drive in the hardest conditions that we could find in Europe. So you can see the team was driving in a snowstorm, and you can see the video in the booth. Snow is pretty unique. It usually comes with the snow droplets, but also with fog. So it's a huge challenge to the visible sensors. So you can see the backscatter. You can see how hard is it to recognize the road further ahead. Comparing to the gated imaging, again, we do not have the backscatter effect, and we are unaffected from the snow particles in the air. Seeing further along the roads, easy to detect the road surface, to detect the sides of the road. If you are running detection algorithms, much easier to detect obstacles on the road. Again, comparing that to the thermal imager, I think nothing more for me to add up here. I think it speaks for itself. Last thing before we can move to questions if you have, fog. So we are in sunny Israel, and you would think that here in the Middle East you will not find a foggy condition, but once you're starting to dig into that, it's pretty interesting to understand that even in Israel, we have about 5 to 6 months of foggy condition across the state. Even in the south, even in the center, of course in the winter up in the north. So fog is a challenge, because fog is it's a pretty unique physical condition, something to overcome. So once you need to detect it, and then you need to mitigate it. So with gated imaging, it's fairly easy to sense it and to detect it, and then to apply the right ISP techniques in order to overcome it with the gated imaging. So you can see here still in Lapland, very foggy. You can see the backscatter effect, how it affects the returning light from the headlamps into the visible sensor. But still you get a very clear, a very high contrast in the gated imaging technology. And if you want to get a first-hand impression, you are all welcome to our booth to see videos. And if you have questions, I will be happy to answer.